Children. So glad to have you guys on board. So today we are discussing the chapter System of Particles and Rotational Motion. So just giving you an insight. So last class we have discussed all the concepts based on this chapter, right from center of mass until the concept of moment of inertia of different objects. So that is what we have been discussing. So now we are going to look at different types of questions that can come from your examination point of view. All right. So here,
Manish, if I can ask you one question.
yes,
இது
yes.
வந்து இது 2000 இது 11th standard boys இவங்க.
ஓகே 11th
ஆமா.
ஆமா இது 11th டாபிக் தான் அங்கிள்.
ஓகே சரி தட்ஸ் ஓகே. இல்ல அது நீங்க
நம்ம 12th வந்து ஸ்டார்ட் பண்ணல. So we are doing 11th.
Yeah 11th. Okay. Carry on.
Okay. Yes. So this is the first question that we have on screen. So wherein we have two bodies of mass 1 and 3 kgs. They have position vectors, so that's been specified in the question, as you can see. So I'll underline them. Okay, so the two position vectors have been given. For mass 1 kg, the first position vector, and appropriately for mass 3 kg, you have the second position vector that has been specified in the question. So the center of mass of this system of both 1 and 3 kg is what they're asking. That's the question. You'll have to find out what is the center of mass of this system of two masses. Okay, so I hope you guys are aware about the formula that can be used. The coordinates center of mass, wherein I would represent x coordinate, wherein j represents y, and k would represent z coordinate. So you can find out the coordinates of center of mass of these two bodies, okay, having masses 1 and 3 kgs. Fine. So can anybody tell me what formula would be apt to use in this question so that we can proceed further? Could anybody volunteer? If you have seen the previous material that I posted, you can see the formulas are quite evident. So what would be the formula that can be used to solve this question? Yeah. For x coordinates for x center of mass, and for y, and for z. What is the general formula for center of mass? The mass times the distance from its axis upon the total mass. So we just need to apply that. Okay. So x center of mass, I'm just giving you the formula. Xcm is equal to sigma mi xi upon sigma mi. Okay, this is the formula. Similarly, for y center of mass, you have sigma mi yi upon sigma mi. Okay, the same way for z also. Sigma mi zi upon sigma mi. Okay, so you need to apply in this formula and you need to find out. So what would be the answer for x center of mass? Just you go for a substitution and you can tell me what value you are getting for x center of mass. Anybody? The first one is mass is 1 kg, the second one is m2 is 3 kg as given in the question. So in the question it has been specified, m1 and m2 have been specified. m1 is 1 kg and m2 is 3 kgs. Okay, so appropriately go for a substitution. So upon substitution, what do you get for the first one? So what is mass? Mass is 1 kg. So 1 times, you can see x1 represents, I told you x represents I. So the coefficient of I is 1, right? So 1 times 1 plus m2 is 3. So 3 times, what is the second position vector corresponding to 3 kg? x1 is negative 3, right? So minus 3 upon the total mass. 1 plus 3 is 4. So what is the answer if you go for a simplification? So you get 1 minus 9 upon 4, which is minus 8 upon 4, which gives you negative 2. Okay, that is x center of mass. The same way you find out what is y center of mass and z center of mass. Okay, so for y center of mass, you go for a substitution and then you simplify. You get the answer as negative 1. You can check the answers. And same way for z center of mass, you get positive 1. So once you have found out the individual center of masses of the coordinates x, y, and z, now you go and write down the position vector. X would represent I cap, so we can write it as minus 2i. Y represents j, so it's minus j cap, and z represents k, which is plus k cap. And hence the answer is minus 2 minus 2i minus j and plus k. Okay, so the answer is option C. Third option is right. Okay, this is how we solve this question. Okay, I hope this part is clear. I hope you guys are with me. So this is how we solve this question. Quite a simple approach. Okay, it was an easier one. So eventually we'll look at questions which are tough. So to start off with, we have done this question. Okay, so I hope it is clear. We'll move on to the next part. So I'll give you the second question. So here comes the second question. I'll just write it for you guys. Yeah, here comes the question. A wheel of mass 8 kgs and radius 40 centimeters is rolling on a horizontal road with angular velocity of 15 radians per second. Okay, the moment of inertia of the wheel about its axis is 0.64 kilograms meter square. Determine its total kinetic energy. Determine its total kinetic energy. So I'll give you options. 288 joules, option B 216 joules, and option C 72 joules, option D 144 joules. Okay, I want you guys to try it. Please read the question. One of you can read it and tell me what is the given data. I would really appreciate that. So just yeah.
The mass of the wheel is 8 kilograms and the radius is 40 centimeters. And
Yes.
the angular velocity is 15 radians per second. And
Yes.
the inertia is 0.4 kilogram meter square.
Yeah. So mass we would represent using the letter N. And what about angular velocity? What is the representation? How do you express it? What is the notation for angular velocity? It's represented using a Greek alphabet. So can you just take a guess? Yes, anybody? Linear velocity is represented using the alphabet V. Unlike, how is angular velocity represented? We discussed this in the last lecture, that is yesterday. It is represented using the symbol omega. Is that clear? So omega is 15 radians per second. Okay. And moment of inertia is given by the symbol I. So I is 0.64 kilograms meter square. Okay, so this is the given data in the question. Now, as per the given data, we have mass, we have information about angular velocity, we also have information about moment of inertia. And they are asking us what is the total kinetic energy. Okay, so we need to calculate the kinetic energy in this case. So, how can we approach this question? So, when you have a wheel with certain mass, okay, that is rolling, obviously it is in motion. So, it would possess kinetic energy, right? Because it is in motion. Obviously, it's rolling.
Yes, sir.
So, yeah. So, what is the formula for kinetic energy? This you guys should be knowing. What is it?
So half mv square.
Exactly, it's half mv square. That's the kinetic energy. Okay. Now, when you say that it is having certain moment of inertia as well, so therefore you need to consider the kinetic energy of moment of inertia of the wheel. That also needs to be considered. So therefore, the total kinetic energy involved here is the kinetic energy of the wheel plus it is the kinetic energy of moment of inertia of the wheel. So both needs to be considered in this case. So we might be thinking it's only half mv square, but it's not. You need to consider the kinetic energy of moment of inertia as well. So for this, so what we do, general kinetic energy, you guys know it's half mv square. I'm substituting that plus kinetic energy of moment of inertia because it's having an axis of rotation about which it is also going to rotate about its axis. So therefore, we write that as,
So
yeah, I
half I omega
omega
square.
square. Correct. So we write that as half I omega square. Now, you need to understand that we don't have information about linear velocity. We only have information about angular velocity. But there is a relation between linear and angular velocity. Can anybody tell me what's the relation between v and omega? Both are related.
So v is equal to r omega, sir.
Correct. So v is equal to r omega. Go and substitute, and you can express them in terms of omega. So half m, in place of v you put r omega. So you can get r square omega square plus half I omega square. Okay, this is what we get. Now you can go for a common out and then you can substitute. So you can take appropriate common outs here. Half is common, and you also have omega square as common, right? So inside the brackets you have m times r square plus I, isn't it? This is what you get. Now you go for substitution. Substitute the values. Half. What is the value of omega as per the question? How many radians per second? It's 15. So omega is 15. Okay, what's 15 square? Anybody? 225. Okay, half times 225 within brackets mass. Mass was, I suppose, 8 kgs, right? So 8,
Kilogram.
yeah, 8 kilograms. And what was the radius? Radius was 40 centimeters. So you'll have to convert centimeters in terms of meters. So 40 upon 100, right? So 40 upon 100, simple fraction, I think you get 2 upon 5. So 2 upon 5 the whole square plus moment of inertia, which was given in the question. I think it was 0 point something. Let me just check. Yeah, 0.64. So 0 plus 0.64. Done. So you will have to go for a simplification now. Okay. So simplify it. How much you guys are getting? So it's 225 upon 2 times 8 into 4 by 25. Okay, once you have taken the square plus 0.64, which is, now you need to simplify the one in the brackets first, the terms in the brackets, and then you can tell me the fraction, then finally express in terms of the decimal value. So the one in brackets, can you just simplify and tell me what is the value that you're getting?
Sir, no, so.
1.94? The one in the bracket?
Yeah, somebody is telling 1.94.
Yeah.
Okay. Okay, so in fractions, children, are you able to tell me the fraction so that it's easy, because I'm also working out simultaneously. I'm getting 48 upon 25. I think that's correct, what uncle said. So 1.84, I guess. 1.84, I think it's 1.92.
94. 92.
1.92 வருது. Yeah.
Correct.
So 48 upon 25. நீங்க அது கரெக்டா LCM எடுத்தீங்க அப்படின்னா you will get 48 upon 25. Okay. Just correct me if I'm wrong, because I'm getting this fraction. And நீங்க fraction and decimal convert பண்ணீங்கன்னா you will be getting 1.92. Okay. So it's 225 upon 2 times. நீங்க directly, if you feel that multiplying with decimal is better, because I would like to keep it in fraction. So 48 by 25, because 25 and 225 you can cancel, isn't it? So you can further, you can simplify. So what do you get further when you simplify this? Cancel pannunga and tell me. I think it's getting simplified, right? So you get 216. 216 varudha. When you cancel it, it gets cancelled perfectly, and you get this also gets cancelled, right?
Yes, sir.
Right. So yeah, you get 216. So the answer is 216. All right. So 216. I mean, you should know even the units, because we are talking about energy, kinetic energy. The default unit for energy is joules, and hence the answer is option B, 216 joules. I hope it is clear. So this is how you approach this question. Okay. So step by step, you know how to simplify. So you must be, little quite fast in calculations. So this is a part where you lose time. Therefore, you have to invest time properly and do the calculations much faster. Okay. So this is how you approach this. So let's go to the next question. Any doubts in this question, you can ask me. You can stop by and you can ask. Any doubts here? Is it clear to all of you?
Yes, sir.
All right. So we'll move on to the next question. So here comes the third question. Yeah. So the third question is, one second. Yes, I hope now it's visible again. Yeah. So here comes the third question. So I'll just write it down. Okay. A disk of radius 0.5 meters and mass 2 kilograms rotates in the horizontal plane with its axis as axis of rotation at the rate of 600 revolutions per minute. Okay, 6,000 revolutions per minute. A ring of mass 1 kilogram and internal radius 40 centimeters and external radius 0.5 meters is kept on it with its axis with its axis coinciding with that of the disk. With that of the disk, okay? So the speed of rotation of the disk is now, I'm giving you the options. First option 2.25. Okay, these are all in revolutions per second. So 2.25 revolutions per second. Option B 1.265 revolutions per second, and option C 5.5 revolutions per second, and finally option D 10.5 revolutions per second. The last one is 10.5, not 6. Let me just change it. Yeah, 10.5 revolutions per second. So you'll have to find out what is the rotation of the, what is the speed of rotation of the disk when you have a ring that is going to be placed above it and it's perfectly coinciding with it. Then what happens to the new speed? What would be the new speed? That's the question. Okay, so again, moment of inertia of the disk first you have to calculate, and then moment of inertia of the ring you need to find out. Okay, and then we apply the concept of conservation of momentum. So that's the approach. So first you guys tell me what are the given data, and then we will see how to proceed. We have, how many objects are given in the question? Is it 1, 2, or 3? You have a disk, you also have a ring, right? So primarily you can see that there are two objects involved in this question. It's not a single entity. Okay, you have two objects, two entities. So you have to write down the data for both of them and find out the moment of inertia for both of them. Okay, so calculate and tell me what is, first you can calculate the moment of inertia for the disk. Okay, so we can call it I disk, ID. Okay, or I disk. So what is the moment of inertia for a disk? Having the axis of rotation along its center. We have learned the formulas, right? I've given you the list also. According to that, it is mr square upon 2, right? You apply this formula and you can find out. Okay, so what is the mass? The mass is given in the question, right? It is 2 times radius is also there in the question, 0.5. Okay, so 0.5 whole square upon 2. So how much is that? 2 is getting cancelled off. Get 0.25, right? You get 0.25 kilograms meter square. Okay, per meter square. So this is the corresponding value. Okay, I think kilogram meter square would come. Yeah, so this is the value that you have. Similarly, you find out what is the moment of inertia of the ring also, the same way. So what is the moment of inertia of the ring? Again, you apply the formula, simplify and calculate. Now this ring has got an inner and outer radii. Now there can be questions where you have an inner and outer radii. The thickness is not negligible here. So in this case, you will have to find out what is the moment of inertia of the ring, the entire ring. Consider the thickness as well. Okay, so for that it would be m times r1 square plus r2 square upon 2. Okay, it gets modified like this. So again, go for a substitution. They are saying the ring has a mass of 1 kilograms, so it is 1 times r1 square. R1 and r2 you have it in the question, so 0.4 you can write, right? 40 centimeters can be written as 0.4 meters. So 0.4 meters whole square plus have 0.5 meters whole square divided by 2. Okay, simplify it. So what is 0.4 the whole square? Easy. 4 square is 16, right? So how much is 0.4 square? 0.16.
0.16.
Yeah, so 0.16 plus 0.5 square would give you,
0.25.
yeah, it's 0.25 upon 2. Add both of them. How much is 0.16 plus 0.25? 0.41. We're getting 0.41, isn't it? Upon 2.
Yes, sir.
Yeah, that is nothing but 41 upon 200. Okay, so you can take that 100 up. So I can also write it as 41 upon 2. First I will do that. So 41 upon 2, it's easy to divide. So which is 20.5 into 10 raised to minus 2. Can we write it that way? Yeah. So can be written as 20.5 times 10 raised to minus 2. Then you shift the decimal places, and what do you get post shifting? It will shift 0.
Two
Point,
five
point, yeah, 0.205.
0.205. Yes, sir.
Yeah, you get 0.205. That's it. Okay. So 0.205. So 0.205 is the moment of inertia for the ring. Units is kilogram meter square again. So for both we have calculated the moment of inertia. So we have calculated I disk, moment of inertia of the disk as 0.25, and moment of inertia of the ring as 0.205. We have both the values with us. Now we need to apply the law of conservation of angular momentum. Okay, so you know that momentum is going to be conserved, right? Because it is in sync with law of conservation of energy. So by law of conservation of angular momentum, we can say the angular momentum would be equal for both. Okay, so therefore we need to consider that, and we need to find out. Okay, so here I'll just scroll up to the question. You can see, because they are rotating, the disks which are rotating along a particular plane, you know that they possess momentum which is called angular momentum, because there is rotation that is involved. So therefore the momentum would not be linear, rather it would be angular in this case. So the angular momentum, okay, is going to be conserved. So we apply that relation and we find out. So the angular momentum for both your disk plus the ring is going to be equal to the total angular momentum. So that is what we are going to write the expression for. Okay, so when you write the expression, so by, I can say, by law of conservation of angular momentum. Now who can tell me the formula for angular momentum? In general, angular momentum is given by the letter L, okay, which is having the formula mvr. Okay, this is general formula. But now we wanted to express v in terms of omega. V is anyways r omega, we know that. Okay, that is one way of expressing. One more way of expressing angular momentum is in terms of inertia. It can be expressed as a product of inertia times angular velocity. Now this one is linear angular momentum, okay, and this one is, I mean, this is linear momentum, the first one, okay, and then we have angular momentum expressed in terms of angular velocity. So first one without angular velocity I'm expressing, second one in terms of angular velocity I'm trying to express. So this is the difference. So therefore I would go for the second one, because we have information about, we wanted to find out what is the angular velocity, and therefore I would choose the second way of expressing. Okay, so the total angular momentum can be expressed as the total inertia of the disk plus the inertia of the ring times your angular velocity omega. Okay, so I will express that as angular velocity omega. Okay, so say that omega we don't know, so I'm just keeping it as omega is equal to, now initially before even the ring is being placed over the disk, it is only the disk that is primarily involved. So therefore I can write it as I disk times the angular velocity of the disk, DISC. So I'm writing it as omega disk. So this is how you express the law of conservation of angular momentum. Okay, so wherein the first expression will give you the total moment of inertia. Okay, so now I'm going to substitute the values. So the disk plus ring, so just add them, 0.25 plus 0.205. How much are you getting?
0.4550.
Yeah, 0.455 times omega is going to be equal to the angular. Again, we have the moment of inertia of the disk, which is already 0.25, times angular velocity of the disk. That was already there, mentioned in the question, right? So let me just check that value. Yeah, so that was given as, yes, here we have it. See, 600 revolutions per minute. Okay, so that is the corresponding, that is the value. So you need to convert revolutions per minute to revolutions per second. That's very important because the answers are in terms of revolutions per second. So how can you write 600 revolutions per minute in terms of revolutions per second? I hope you guys know how to go ahead with the conversion, right? So I'll just show it here. 600 revolutions per minute, 1 minute is equal to 60 seconds, right? So how do you write it? 600 upon 60, it became revolutions per second. Then you go for the simplification, right? So you get 10. So it's now 10 revolutions per second. So 10 revolutions per second. So go for the simplification. So you can know that omega is equal to 0.25 times 10 upon 0.455. Just you need to simplify this, all these terms. Okay, so it's better that you go for a simplification. Can be written as 25 into 10 raised to, I'm directly doing it, 25 by 100, that 100 is 10 power minus 2. So already you have a 10, so it becomes 10 power minus 1 upon 455, can be written as, 0.455 can be written as 455. Okay, times 10 raised to minus 3. Okay, so I'm writing it like that. Fine. Now you go for a simplification. 25 upon 455, you can simplify. How much you get if you simplify that? You need to cancel out. Okay, cancelling is very important. 25 5s are 455 goes 4 9s are and 1s are. Yeah, I think you get 5 upon 91 into 10 raised to minus 3 goes up, it becomes plus 3 minus 1 would give you, yeah, would give you 2, right? So it's 2. So 500 by 91. How much is 500 upon 91? You will have to find out in decimals. You will have to go for a division now. Okay. How much you're getting? You'll get something 5 point something.
5.49.
Yeah, 5.49. Okay, revolutions per second. That's it. So 5.49. So that's the value that you are getting. Okay. 5.49. If you approximate it, can we write this as 5.5? No harm. Same thing, right? So when you go for an approximation, so which is approximately 5.5 revolutions per second. So what is our answer? Which option is right? You can see option C. Third option, 5.5 revolutions per second. That's the answer. Okay. So again, the crucial place here that you will have to take care of is your substitution, simplification, and especially the part where we applied the angular law of conservation of angular momentum. Okay, so even before you add the disk to the rotating, add the ring to the rotating disk, so you need to consider the momentum before addition of the disk, addition of the ring, and after addition of the ring. Before you add the ring, the moment of inertia of the disk needs to be only considered. After you add the ring to the rotating disk, you need to consider the entire entity, that is moment of inertia of the disk as well as the ring. So that is what we have done here. Okay, so if that you understand logically, it's very simple to approach this question. So that is the main idea. So that's how you need to approach. Okay, so that has to strike. So if you think in that direction, you can easily get it. Fine. So this is how you approach this question. I hope you guys have made a note of how to approach these type of questions. So where you have two objects, one inserted over the other, where one being rotated and the other is initially static. And once the ring is attached, then they will start rotating as a single entity. Okay, that's the reason the angular velocity is same. When the ring is inserted to the disk, the ring would start rotating along with the disk. Okay, so the velocity would be common for both the ring and the disk post insertion of the ring. I hope you logically get it, right? So that is how you need to understand this question. Substitute, simplify, and then deduce the final expression and the answer. Okay, final answer you get it as 5.5. Yeah. Is the question clear? Shall we proceed to the next one?
Yes, sir.
Okay. Moving on to the next question. The fourth question. So, yeah, here comes the question. The moment of inertia of a hollow, say, of the hollow sphere, okay, of the hollow sphere of mass m, okay, it's capital M, it might look like small m, it's actually capital M, sphere of mass capital M, and internal and external radii here we use the term radii. Radii is basically the plural version of radius. Okay, so please don't get confused. When I say radii, I'm referring to more than one radius. That's the meaning. So having internal and external radii r and 2r about an axis passing through its center about an axis passing through its center and perpendicular to its plane. And perpendicular to its plane is. So we have the options here. I'm giving you the options. Option A, 3mr square upon 2. Option B, 62mr square upon 35 upon 35. And option C, 13mr square upon 22. And option D, 31mr square upon 35. Okay, so these are the four options. Okay, so I want you guys to carefully read the question and tell me what's the given data. Would be great even if you can tell me what formula can be used. Yeah, first you tell me the given data and then we can see how we can proceed further.
The mass of the hollow sphere is the internal radius is r,
Yeah.
and we have to find its mass.
Yeah. Okay. So mass is m and internal external radii is r and 2r about the axis passing through its center. Okay. That's it. So what formula can we use here to solve this question? So they've given a sphere. So what is the they're telling it's a hollow sphere. Okay, that is also mentioned in this question. So it's a hollow sphere. So what is the moment of inertia of a hollow sphere? Anybody? The moment of inertia of a hollow sphere. Wherein the axis is passing. We are saying here it is passing through the center. you say center, it's basically about the diameter, right? That is the meaning. Okay, so having access through center. Okay, when they say having access through center, now you know that it would be 2 mr square by 3. Okay, this is a general formula. Now here they have given you the internal and external radii, both have been specified appropriately. So when they specify both the terms, so what can we do in such cases? You need to substitute both of them, right? You need to consider both of them, isn't it? So what can you do here? So you need to incorporate both the radius. Okay, so go and incorporate both the radius and tell me what would happen to the formula. Just you need to simplify it, that's it. You simplify it, you will get the answer. As simple as that. Substitute the values r and 2r in the expression so that you get the effective radii, and then you need to get the answer for this. That's it. Okay, that's how you have to approach this question. Yeah, just try it and tell me what answer you're getting. I want you guys to also try it and tell me what's the answer that you're getting. Yes, I hope you guys are trying it. Because you have inner and outer radii, what happens to the moment of inertia? So for the entire sphere, it needs to be calculated. It's not just the part of the sphere. Can you tell me what is the volume of a sphere? There's a little bit of mathematics involved here. What is the volume of the sphere? Anybody? So volume of the hollow sphere we need to first find out. Okay. So that is nothing but, it's 4 by 3 pi r cube for a solid sphere. Because it's hollow here, it is smaller radii minus, bigger radii minus the smaller radii. Okay, and it's r cube. So 2r the whole cube minus r cube. Okay, so we need to go and substitute the values. So substitute the values, go for a simplification. You get volume is equal to, so 4 by 3 pi 2r cube minus r cube. Just go for a simplification. It's 8 r cube minus r cube, where you get 7 r cube. Okay, so times 7 r cube. So this is what you get, and multiply 4 and 7 and simplify, you get the value as 28 upon 3, right? 28 upon 3 pi r cube. So this is the volume of the hollow sphere, whatever you call it. Okay, the hollow sphere that is there. So once you have found out this, then you need to find out what is the density, because we have to identify, we are going to calculate the moment of inertia considering that there are there is a bigger area and there is a smaller area which is specified. In that case, you cannot directly use the formula. So we are going by this approach. Okay, so find out the density. Then density is mass upon volume. The mass is m and volume is 28 by 3 pi r cube. So you use this relation. Okay, and then what happens? We have to find out the moment of inertia. You know that moment of inertia I is given as, can be expressed as a summation also. You can express as a summation. Okay, so we express that using integration. So integration of di, the entire moment of inertia for the hollow sphere needs to be considered. Now when I say hollow sphere, it is from radius, limits would be radius r to 2r. Okay, only that area we want, only that region we want for that corresponding thickness. So therefore we go for an integration. So substitute it, and then you need to simplify, you need to integrate here. That's how this question needs to be done. So the limits are from r to 2r. Now I go and substitute the corresponding value. So what is di? So mass of that small shell would be dm. M mass is, total mass is capital M. But when you take a small slice, in that case, what is the mass? That would be dm. So smaller mass is nothing but density times that corresponding smaller volume. Okay, so when I say the volume, I am only going to consider the corresponding, the small thin shell, that area only I am going to consider. So which is 4, so say which is 4 pi x square times dx. So I'm just considering the volume of that small, particular area or that slice that I'm considering. And then you add all the slices, you will get for the entire hollow hemispherical, shell, that entire sphere, hollow spherical sphere. Okay, so we will get it for the entire thing. That's the reason I'm going for integration. So therefore integrate. So 2 to 2r. So I'm integrating, substituting all the values. So what I get for the smaller moment of inertia. So di is equal to 2 by 3 dm into x square. So we get the expression like this. So integration is basically being done here. So substituting the values, I get 2 by 3 rho. Then you know that it is 4 pi x square. So I'm substituting 4 pi x square times dx into x square. Now this is all integration concept. So basics of integration, if it is clear, this is an easier approach for us. So take all the common outs out of the integral sign. I hope you guys know all common outs can be taken out. So 2 by 3 into density can be written as mass by volume. So we have m upon 28 by 3 pi r cube, which was the volume which we had calculated before, into 4 pi x square. You have to take it inside the integral sign because it's an integral factor related to an integral factor. So times r to 2r, integration, the limits are from r to 2r. Okay, and it is, now when I say, you can see that there are x square into x square, 2x square terms, so x to the power 4 would come into dx. Okay, integration of x power 4 dx, you need to go for you have to evaluate that. Okay, now this 28 by 3 and this 2 by 3, after you take the reciprocal, okay, and you go for a simplification, so finally what expression you get, and again there is a 4 also. Okay, not to forget that term. So 2 3s are 6, 6 4s are 24, so all the values are there. Okay, so go for a complete simplification. Whatever the values you have, simplify it. So I will write it separately for you guys. So 2 upon 3 times, then you go for a reciprocal, which is 3m upon 28. Pi is going to anyways get cancelled off. Okay, upon 28 r cube. Okay, and not to forget, there is a 4 also on the top, into 4. So integration r to 2r. So now you have x power 4 into dx. Before you integrate, the basics of integration, there is a formula for integration, which is integration of x power n into dx is x to the power of n plus 1 upon n plus 1 plus c, where c is your arbitrary constant. So I go and substitute that, and then I go for simplification. Okay, that is what we are going to do. Substitute, then you simplify the corresponding values, okay, whatever are left. So that's what you need to be doing. So what do you get when you go for a substitution? Okay, so integration of x power 4 is x power 5 upon 5. That's what you get. Okay, so it is x power 5 upon 5. I'm writing only that part. Limits from r to r. Okay, so that needs to be simplified. You can simplify that as 2r to the power 5 minus r power 5. Okay, 2r power 5 minus r power 5 is, again, simplify it, substitute the values and multiply. You will get the answer as I is equal to, so I'm substituting the value, so you get it as 2 by 3 was there, we had 3m on the top, 7r cube into 31 by 5 r to the power 5. When you go for the simplification of this term, you will get this term. Now multiply all the terms and go for a simplification. So you will get the answer as 62 r square upon 35. So this is the value that you will get. So it involves integration. It's a high level question. So this is how you approach this question. This one, requires, integration concepts. And you guys being in 11th, this might be, going above your head, because integration still you guys are not having an idea of integration. Calculus, you'll just be learning derivatives as of now. So this, might be a little difficult. Okay, so this is how you have to approach this question. Anyways, this we can even, see it later. So yes, I have solved it. So this answer is actually option D. This is the answer. So that's how you approach this question, step by step approach. Okay, it's not difficult. If you just learn, the basic formula of integration, this is going to be easy. Okay, just application of integration. Again, you will have to simplify, of course. So integration by substitution method is being used, and then it is being simplified. Okay, so that's how this question is being done. This is a little difficult to understand now, but once integration is clear, you will be able to understand it. Okay, so I'll take a session also for calculus. Don't worry, a bridge course, kind of a uh, class also can be arranged. Okay, so where we can bridge up the gaps of calculus, be it differentiation or be it integration, we can do that. Anyways, maths, sir also might be teaching you guys, but anyways, we'll have it. How much ever we require for physics, we can definitely bridge up that. Okay, because it's necessary. Fine. So that's all about this type of question. So you need not feel that this is very difficult. It's simple. Once you know integration part, it's easier. Okay, because now it will be different for you. It might be Greek and Latin, but eventually you would get accustomed to solve questions like this, which involves calculus. All right. So yeah, so we'll move on. So this is on the higher end. So we'll move on to the next question. Okay, we'll see questions which does not involve calculus, not that much of calculus. So yeah. So here comes a question. So where you have two spheres. So move on to the next question. Two spheres each of mass m and radius r upon 2 are connected. Okay, are connected with a massless rod of length of length 2r as shown. Okay, so here we have a figure. So this is the figure. You have two spheres which are connected by a massless rod like this. It is end to end connected, and the mass of the spheres are m, Both are identical spheres. Okay, so the length with respect to their centers is given as 2r. Okay, this is 2r, and the sphere's radius is r upon 2. That's the radius value. Okay, this is the given data. And continuing the question, so moving on to the question again. So I've given you the figure. The moment of inertia so the moment of inertia of the system about an axis passing through the center of one of the sphere and perpendicular to the rod. And perpendicular to the rod is, I'll give you the options. Option A, 21 mr square upon 5. Option B, 2 mr square upon 5. Option C, 5 mr square upon 2. And option D, 5 mr squared upon 21. Okay, so these are the options. So there's a question. The question consists of a system of two spheres having radius r upon 2, and they are connected using a massless rod having a length of 2r. They're asking you what is the moment of inertia of the system about the axis passing through its center of one of the sphere. Okay, through one of the sphere you have the axis of rotation. Given that condition, they're asking you what would be the moment of inertia of the system. Okay, just try this question. Try to visualize it, draw the figure along with the axis of rotation, so that you can have an idea of how to proceed. Okay, so what do you mean that there is an axis of rotation along one of the spheres passing through the center? So it can be left side or right side. You can choose any one sphere of your choice. It is like this actually. Okay, this is rotating with some angular velocity omega. That's the mean. All right, so if you have the axis along one of the spheres, then they are asking you what is the moment of inertia of the entire system. Okay, so then in that case, what would be the moment of inertia of the entire system? So you have two spheres. You have to consider both of them. Okay, so that's necessary. So for each sphere you have to consider. So let us name both the spheres. Let me call the first sphere as, say, sphere A, and let this be sphere B, the second one. Okay, so find out what is the moment of inertia when you have an axis of rotation for sphere, say for the first sphere B. We'll go to the right one first. So what is the moment of inertia provided that you have an axis of rotation along its center? Right, you have a ready-made formula for that. What is it? The moment of inertia for sphere B. So how can we write it? It's 2 mr squared divided by 5, right? This is the formula by default. So you know that the radius is r upon 2, isn't it? But not to forget that you also have a rod of length. That rod is also going to rotate, right, along with the sphere. We have not forget. So you need to add the moment of inertia of that rod also, which is mr square, right? So mr square we are going to take. But so what is the length of that rod? The length of the rod is 2r. Okay. So I will write it as r square. Small r I will use to just differentiate. I mean to distinguish between both the terms. Okay, so this becomes 2 by 5 m. What is the radius of the sphere? Sphere B, the radius is r upon 2, right? So you will put r by 2 the whole square plus now m. This r is nothing but the length of the corresponding rod. So what is the length of the rod? Let's again come back to this page. Let me go back. Yeah, so length of the rod is 2r. So I'm substituting here 2r to the whole square. Okay, simple. Now you go for a simplification. You simplify this, what do you get? The left hand term, it's mr squared upon 2 square is again 4, 4 5 are 20, and 2 upon 20 is 1 upon 10, right? So you get mr square upon 10 plus then 2r square the whole 2r the whole square would give you 4r square. So it is 4mr square. You can again go for a common out and then you can simplify. Mr square is common, then brackets 4 plus 1 upon 10. How much is 4 plus 1 upon 10? Go for an LCM. 40 plus 1 upon 10. So I hope you get 41 mr square by 10, isn't it? You go for an LCM. Okay, that's it. So this is what is the moment of inertia of the sphere B. Same way you find out for sphere A also. Okay, that also you need to calculate. So for sphere A, again same thing, right? 2 mr square by 5. Okay, so again you simplify this in place of r you put r by 2 because that is the radius of the sphere. So 2 by 5 m, this is r upon 2 the whole square. So go for the simplification, you get mr square upon 10. So that's it. Now you need to add both of them to find out the total moment of inertia. Okay, so find out the total moment of inertia now. So I total is equal to IB plus IE for both the spheres. So which is 41 mr squared upon 10 plus mr squared upon 10. So you know that mr squared by 10 is common out. What do you get? The final answer is 41 plus 1, which is 42 mr squared upon 10. Okay, so you get 42 mr squared upon 10. So you can go for a simplification. Okay, so you simplify it and then you try to find out what is the final expression. Okay, that's it. Simplify it, add them, simplify it, and then find out the total expression. What is the final answer that you're getting? You can go for a cancellation, right? So when you cancel, 2 2s are 2 1s are, so I think you get 21 mr square by 5. That's it. So that is the total moment of inertia. That's the final answer. Okay, so 21 mr square upon 5. So the answer is option A. So this is the answer. Okay, so that's how you approach this question. This one is quite simple. It's not that complex. So for each sphere, find out. For the first one by one, you need to calculate. Okay, and not to forget, you also have a rod that is attached in between. So joining their centers, so you need to keep that in mind. So therefore, that is 2r. The length is 2r. So you need to consider that as well. Okay. So this is how you approach this question. I hope this part is clear, right? So you do it step by step and you add both the results, you get the total moment of inertia as 21 mr squared upon 5. Okay, that's how you do this question. Okay, So I hope this part is now clear to you guys. So fine. So we'll move on to the next question.
Sir, can we print the answer in decimals, sir?
Pardon? Answer in decimals, but not necessary because options are not in decimals; they are in fractions, right? So you can leave it at that.
Yes.
Okay. In case if they have given in decimals, then obviously you would further simplify in decimals also and express it. Okay. But here it's not needed. Okay. Yeah. We'll move to the next question, a different model this time. So we'll move to the next one. Okay, so please practice the questions that we are doing because I'm touching, all different kinds of questions. So if you're doing these questions, it will be very useful because you get accustomed to different variety of questions. So you will have an idea of how to approach. Okay. So moving on, seventh question on the screen. So here comes the next question. Okay. So now we're seeing the next question. So here, a T-shaped lamina. Lamina is nothing but an object. Okay. So a T-shaped lamina with dimensions as shown below. Okay, as shown is lying on a smooth floor. Is lying on a smooth floor. Okay, and a force F is applied. Force F is applied at a point P. Is applied at a point P parallel to AB. Okay, such that the object has translational motion without rotation. Okay, without rotation. The location of P with respect to C. With respect to C is. So I'll first draw the figure and then I'll give you the options. So here we have the figure. It's a T-shaped lamina. That's a T-shaped object. So this is how it is. The shape of a T. So I'm giving you the dimensions also. So this end is A, this end is B, and this is C at the bottom. Okay. And you have a point P which is there here. Same way. Yeah. So you have a point P here. And the length is also given. The force is applied. So I'm now showing you that part also. This is a point where force is being applied. And this is length L. And this length from here to here, it is 2L. Okay, so these are all the dimensions. Okay, so once the dimensions are given, so you will have to find out what is the location of P with respect to C. C is at the bottom. Okay, with respect to C, you will have to find out. Okay, that is the location, the moment of inertia. The location of that we need to find out. So I'll give you the options. Option A is L and option B is 4 upon 3L. Option C is 2 upon 3L. and option D is 3 upon 2L. These are the four options. Okay, so you'll have to find out what is the location of P with respect to C for this question. Okay, so again, with respect to center of mass, you need to find out. Okay, so assume that there is a uniform mass per unit length. Okay, the linear mass density is uniform because it is both the rectangles which make up the T-shaped lamina are identical in nature. It is made up of the same material, so therefore, the linear mass density is going to be same for both. So you find out what is the mass that is going to act, and then you will calculate what is the translational motion of P with respect to C. Okay, so force is acting exactly at that point P. That's what we have told in the question. So in this case, how can we approach? You just need to assume that, say, you're assuming some variable. Okay, so let let us say x be the mass per unit length. Okay, mass per length. So that is x. If I say that is a mass per length, then what is the mass of AB of the rod? So mass AB, what would be the mass AB? So you know that mass AB, I can write it as M AB is equal to mass per unit length is x I have taken. So x times L. Okay. So x by L into L, anyways, obviously you're going to get the corresponding, mass because x is mass per unit length. That's how I have taken. Okay. It is acting. At which point it is going to act? It is going to act exactly at the center of mass of the rod of length, L. So exactly at L by 2. So somewhere here it is going to act. Okay. So let us say that point as O. Okay. So it will act at O. If I'm going to take. Okay. So what is the mass of, say, now OC? So now you have another part also. You will consider OC also as another vertical rod. Okay. So what is the mass of OC? So MOC I will keep. Again, I told you it is same, mass per unit length is same, that is not going to change. It is x into length. This time length is going to be 2L if I'm going to consider from here to here. So only this point you will consider. So it is going to be 2L, x into 2L. Okay, that's it. So you consider that point. Okay, so now here they have already told in the question that P is your center of mass. As P is center of mass and you have a force acting at P, therefore you can write that the center of mass at point P is going to be balanced by both O and the point below it. So both it is going to be balancing. So we can write the mass per unit length M times the length of the rod AB, which is L. So we are applying the principle of moments here, times the total length. Okay. So I'm going to apply the total length. So you find out what is the total length. So how to find out the total length? Subtract the bigger length from the smaller length. Okay. So let me go up. Mass per unit length we have taken it as x. Okay. And the length is L. So we can write this as L minus M. Okay, is equal to 2 times for the second, the one which is at the bottom, that is OC, the rod OC. For that also we will consider, which is 2 ml into, I think the variable is also given in the question. Let me just check it. Yeah, force is acting F. Okay, fine. So that also they have specified. So it is 2 m is again the mass per unit length. okay, into say some x. Let me take it as x because m is already taken. Let me just change it. Okay, so let me take it as okay. X I have taken. Let me take it as y because x is already considered as mass per unit length. So arbitrary, I will calculate. I will just write it as y to just distinguish between both of them. So we need to find out what is that corresponding value of y. So go for a simplification. Okay, so simplify it. You can see that when you go for a simplification on both the sides, we have m getting cancelled off. Okay, so that goes away. You will get x is equal to, y is equal to, x term doesn't come into picture here. Y is equal to L upon 3. You will get this particular expression. Two expressions, 3x is equal to L, or you can say, 3 y is equal to L, or y is equal to L upon 3 when you go for a rearrangement. So this is what we typically get. So once you get this, go and substitute. Therefore, the mass will act at the point along the length AB, so which is L, plus this L by 3 which we have found out. So we need to add both of them. So which is 3L plus L upon 3, that is 4L upon 3. So you would get the answer as 4L by 3. So for the entire thing you need to consider 4L by 3. So answer is option B. So when you have objects like this, when there is a horizontal rod and then you have a vertical rod, always your approach is one by one you will decode and then you will find. Center of mass of the horizontal rod here, center of mass of the vertical rod is going to be here, then combined center of mass is going to be here. Now that is generally how we approach. But here they have already given you a center of mass in the question. By default they are saying it is at P. In that case you will take center of mass as O. Then for the vertical rod again center of mass, it might not be P, it might be somewhere here. Then combined center of mass is only P. That is how you are supposed to assume. Okay, because here center of mass is already specified because they say there is a force acting at that point P parallel to AB. Therefore, you will have to consider the center of mass for the vertical rod at the bottom and not at that point P. Combined one I'm saying. Then only you can approach this question. That is the only twist in this question. Otherwise, these steps are going to be similar. Okay. So that is how you do for this question. You proceed for this question to solve it and then find out at that particular point. Okay. So please go through the problems that we have seen in today's lecture. Practice all the questions. Go through them. That's the reason I'm taking some time and doing it slowly. Okay, so that it's easy for you guys also to digest as we slowly go. Okay, so practice these questions, children. So I think that's it for today. We have done a couple of questions based on different concepts. Okay, so yeah, again we can meet up in the next lecture. Okay, meanwhile you can go through them and any questions, doubts you can ask me. Fine. Yeah. Yeah, so no doubts. I hope it's clear.
Yes, sir.
Okay, so practice it, children. You can only get doubts once you practice. Once you practice and you don't, then you will come to understand, where you are exactly getting stuck. Okay, now things might be clear because I have explained step by step. So when you do it, when you're on the pitch, that is when you would experience. Okay, here you're not able to get it or you face some difficulty. That is when you will have the actual questions or queries coming up. Okay, so you can just circle around those areas and keep so that next class we can discuss on that. Okay, yeah, things might be a little difficult but eventually through practice it becomes easy. Okay, you need not worry, we are here to help you out. All right. Okay. Thank you, children. I hope you don't have any more queries. You have any queries, you can ask. So shall we wind up?
Yes, sir.
Yes. Okay, dear. Fine. Take care. So bye bye. See you then.